Welcome to trigonometry. Trigonometry is the study of triangles. A triangle is a two-dimensional shape formed by three line segments. Specifically, every line segment intersecting the other two line segments at its endpoints. What do I mean? Let's draw three line segments. Okay, and denote them by letters AB, BC, and AC respectively. So the three line segments in this shape are AB, BC, and AC. So consider AB. AB intersects the other two line segments BC and AC at B and A respectively. Similarly, the line segment BC intersects AB and AC at B and C respectively. Finally, the line segment AC intersects AB and BC at A and C respectively. So these intersection points are called vertices. So the vertices in this case are A, B and C. And every two intersecting lines form an angle. An angle is represented by this curvy line attaching the two sides that forms it. And they are represented usually by Greek letters like theta, psi and pi. We will learn more about angles in the next lesson. In this lesson, we will learn how to identify if an angle is in a standard position. Let us draw an xy plane. So x and y axis intersect at the origin. So this is the positive x-axis, the positive y-axis, and this is the negative y, and this is the negative x. So for an angle to be in a standard position, it has to satisfy two rules. The first rule is one of the sides of the angle should overlap the positive x-axis. And the second rule is the vertex of the angle should overlap the origin. So if an angle satisfies these two rules, it is said to be in a standard position. So let us take an example to illustrate an angle which is in a standard position. So rule number one of the sides should overlap the positive x-axis. So let's begin with drawing a line which overlaps the positive x-axis. Let's call this line RS. The vertex of the angle should overlap the origin. So we have to make sure the vertex of this angle is at the origin. So there are many ways we can draw these angles, but I have opted to draw this in this way. We call it RT, and this angle is theta. Theta is said to be in a standard position because it satisfies the rule number one where RS is overlapping the positive x-axis and the vertex R is overlapping the origin. So angle theta or TRS or simply R, angle R, is said to be in a standard position. Let us look at few more examples to determine if some of these angles are in standard position. Let's begin by drawing the xy plane. So this is the positive x-axis, positive y, negative x and negative y. So let's begin by drawing one angle which is A, B, C denoted by theta. Is theta in a standard position? So if you recollect the rules, for an angle to be in a standard position, one of its sides should overlap the positive x-axis, and in this case BC is overlapping the positive x-axis. So the rule number 1 is satisfied. Whereas the rule number 2 says the vertex of the angle should be at the origin. In this case, the vertex, which is B, is not at the origin. So this angle theta is not in standard position. Let's look at another example. So in this example, we have an angle psi formed by RS and ST. So is psi in a standard position? Let's look at the rules once again. So one of the rules is one of the sides of the angle should be overlapping the positive x-axis. In this case, ST is overlapping the positive x-axis. So rule 1 is satisfied. Rule 2 says the vertex should be at the origin. In this case, the vertex S is at the origin. So psi or angle RST or angle S is in standard position. Let us learn more about angles. Consider this triangle ABC, which has the angles theta 1, theta 2 and theta 3. In this case, if you observe, every vertex has one and only one angle. So in this case, we can represent the angles theta 1 by just using the vertex name angle B. Similarly, theta 2 as angle A and theta 3 as angle C. Whereas in cases where the same vertex is shared between angles, for example, in this case, the vertex D has two different angles, theta 1 and theta 2. Similarly, vertex A has two angles, theta 3 and theta 4. So in these cases, it is not right to just denote the angles with the vertex names. For example, if I said theta 1 is equal to angle 3 D, that would be a wrong way of denoting the angle, because D has two different angles, theta 1 and theta 2, and it will be ambiguous to represent it this way. In cases like these, we use a 3-point notation, which is in a particular sequence, starting with a point which is on one side of the vertex, followed by the vertex, and then lastly the other point which is on the other side of the vertex. For example, in the case here, theta 1, the vertex is D. So we have to start with a point on one side of the vertex. So here A is on one side of the vertex. Then we write the vertex and then follow it by the point which is on the other side of the vertex, which is B. I could have also represented the same thing, angle, with BDA, starting with B, which is on one side of the vertex, then D, and then ending with A, which is on the other side of the vertex. So for cases like these where the vertex has multiple angles, it is very essential to represent the angle using this 3-point notation. In this lesson, we will learn about the sides of the angle. Consider the xy plane, and as you see, there is an angle theta in this xy plane which is in standard position because one of its sides is overlapping the positive x-axis and its vertex is overlapping the origin. So for any angle which is in a standard position, the side which overlaps the positive x-axis is called its initial side. So in this angle, the initial side is BC and the other side is called the terminal side. In this lesson, we will learn about coterminals. In order to understand what coterminals are, let us look at this example. So I am drawing an xy plane with a positive x, negative x, positive y, and negative y. And I am drawing another xy plane, positive x, negative x, positive y, and negative y. Now I'm going to draw an angle which is going to be in a standard position. So draw an angle A, B, C, and I'm going to draw exact same angle on the other side as well. So A, B, and C. If you observe closely, there are two angles formed at the vertex P. One is formed by moving from the initial side to the terminal side in the counterclockwise direction, and let us call that theta 1. And the other angle is actually formed by moving from the initial side to the terminal side in the clockwise direction, and let us call that theta 2. The angle theta 1 is smaller than angle theta 2, as you can make from the graphs. Another thing to note here is both of these angles share the same terminal side AB or BA actually, right? Terminal side BA, and these angles are said to be called coterminals. So if two angles share the same terminal side, then they are called coterminals. And when you learn about trigonometric ratios in the future lessons, you will observe that theta 1 and theta 2, even though they are different, they will have the same exact trigonometric values. Let us draw an angle which is in standard position. So we begin by drawing the xy plane. We'll name the axis, the positive x-axis, positive y-axis, negative x-axis, and negative y-axis. And also, if you observe, these two axes divides the plane into 4 quadrants, and we name them first quadrant, second quadrant, third quadrant, and fourth quadrant. So now we will draw an angle which is in standard position. The rule says one of the sides of the angle should overlap the positive x-axis and the vertex of the angle should be at the origin. So we'll draw another line here. We'll call this A, we'll call this B, we'll call this C. So this angle is in standard position, and as you can observe, this angle has been formed by moving through the first quadrant and ending at the second quadrant. Now if I asked you to draw an angle which is opposite to this angle, so you would do it by simply moving in opposite direction. So the standard angle that you see here, which is probably theta, which is angle BAC is theta, right? And in order to form this angle, we moved in the counterclockwise direction from the first quadrant and ended in the second quadrant. In order to draw an angle which is opposite to this, we will start with the same initial side, but we will move in the clockwise direction and we will move the exact distance. So we will start by moving through the fourth quadrant and we will end in the third quadrant. So this angle, which we can call it as beta, is exactly opposite measure to the initial angle that we had, theta. So we can say theta is equals to minus beta. Again, in this lesson we will talk about angles. Measurement of angles. Again, let's start with the xy plane. There are positive x, usually three different types of units of measure for angles. X, the first one is negative y. Revolutions. We begin by second is drawing an angle. Degrees. And third is radians. Standard position. So let's draw an xy plane one more time. A, B, and C. We are going to draw a special case of a standard angle here. So the initial side, so the problem the here positive x-axis asks you to measure theta AB. So in the previous lesson we have seen that terminal side, if we also traverse, is on the same one full circle x-axis, we call that is one C. revolution. And the way we ended up here is, if you degrees, which is observe closely, the initial side radians. AB, we started moving in clockwise direction, counterclockwise direction through the first quadrant, second quadrant, third quadrant, fourth quadrant, and ended at the our angle theta positive happens to be exactly 1/4 of the AC total revolution, because one revolution passes through 4 different quadrants, and our angle theta happens to be exactly and this angle equal to 1/4 of the total revolution because it theta ends at the first quadrant. So theta is equal when an angle theta is formed in by traversing a complete circle, is the degrees of so unit of measure for this angle is equal to 1/4 times 1 revolution, which is, so here theta is 90 degrees, and one revolution is same as equal to 2 pi by 4, which is equal to same as pi by 2 radians. So the golden formula that I would want you guys to remember is couple more examples is 360 degrees equal to learn more about measuring angles, radians. Okay, so if an angle is given in 1 unit of measure, by using this formula you would be able to convert it into other units of measure. 0.6 revolutions. Which quadrant does the terminal side end in? So this is a question. In order to answer this, let's draw the xy plane. So as discussed before, this is equivalent to 1 revolution. This is 0.25 revolutions. This is 1 revolution, right? This would be equal to 0.5, and this would be equal to 0.75 revolutions. So in our case, we are saying the angle measures zero point 0.6 revolutions. So it is definitely more than the second quadrant, but less than the third quadrant, because the angle ending at the third quadrant is 0.75 and angle ending at the second quadrant is 0.5. So this has to somewhere be ending here in the third quadrant. So the answer to this question is, if an angle measures zero point 0.6 revolutions, it will end up in the terminal side of that angle will end up in the third quadrant. As you know, this is first quadrant, this is second quadrant, this is third quadrant, and this is the fourth quadrant. The angle here, as you can see, the terminal side, as you can see over here, is ending in the third quadrant. Similarly, now let us look at one more example which will give us a better picture on measuring the angles. So if an angle, so if an angle measures 250 degrees, which quadrant does the terminal side end in? So in order to solve this problem, I would suggest we will draw some guides here. So we'll draw the xy plane once again, and we'll start by drawing some guide. So we know that an angle ending it here is measuring 90 degrees, and the angle which ends up here is 180 degrees, and the angle which ends up here is 270 degrees, and the one which ends here is 360 degrees. So let us draw some additional lines. So these dotted lines divides the quadrants into exactly two halves. So this makes it the 45-degree angle, and this one would be 90 plus 45, which is 135, and this would be 215, and this would be 315. This would be, sorry, 225, and this is 315. Yes, it's correct. So with these guides in place, now it is very easy to answer the question. So we are looking for a angle in a standard position which measures 250 degrees. So we start with one of the sides overlapping the positive x-axis, and we should end our terminal side in a quadrant that would contain the 250 degrees. So as you can see, the third quadrant, let's name the quadrants 1, 2, 3, and 4. The third quadrant ends at 270 degrees. So our terminal side is somewhere here, which would be 200, we call it C. This would measure 250 degrees. So this is another way of dividing the xy plane with guides, so that it gives us a reference to how to measure angles and find out in which quadrants the terminal sides end in. In this lesson, we will learn about how to convert an angle in one degree of measure to another from our golden formula, we know that one revolution is 360 degrees, which is equal to 2 pi radians. So if I were to ask you to convert 225 degrees into radians, the approach you would take is as follows. So we know 360 degrees is equal to 2 pi radians. So what is 225 degrees, right? So by cross multiplication, you know that 360 times x is equal to 2 pi into 225. So in this case, x would be 2 pi into 225 by 360. So we can use multiplication here. So that's 5 times 4, 5 times 5, 5 times 7, 35, and that gives you 2. So 45 and 72. Here you have 2 times 1, you have 2 times 36, and this is, can be still multiplied into like 3 times 15, 3 times 12, further 3 times 4 and 3 times 5. So that's equal to 5 pi by 4 radians. Now let us look at one more example. Here the problem is in the reverse, where I'm given the angle in radians and I have to convert it into degrees. For example, what's 2 pi by 3 radians in degrees? So going back to our formula, 360 times degrees is 2 pi radians, and what's 2 pi by 3 radians? So simple math. So 2 pi by 3 times 360 is equal to 2 pi times x. So 2 pi cancels out, and 3 times 3, 1, 2. So x is equal to 120 degrees. So this is how you convert angles from one degree of measure to another. The golden rule is always, if you keep this formula in mind, you can convert pretty much very easily from one degree of measurement to another. In this lesson, we will learn about complementary angles. Two angles theta 1 and theta 2 are said to be complementary if theta 1 plus theta 2 is equal to 90 degrees or pi by 2 radians. Let us look at this graphically. So let's draw our xy plane. We have learned in the previous lesson that an angle whose terminal side ends on the positive x-axis is 0, 360, this is 90, this is 180 degrees, and this is 270 degrees. Let's draw two angles, and let's name them A, B, C, and D, and the angles are theta 1 and theta 2. As you observe here, theta 1 plus theta 2 will be equal to 90 degrees. In this case, theta 1 and theta 2 are said to be complementary angles. Now let us look at a problem and try to put the complementary angles principle into practice. So for instance, if I tell you theta 1 and theta 2 are complementary, and if theta 1 is equal to pi by 12 radians, what is theta 2? So the problem states that theta 1 and theta 2 are complementary. That means theta 1 plus theta 2 is pi by 2 radians. And we know that theta 1 is equal to pi by 12 radians. So let's substitute that. So pi by 12 plus theta 2 is equal to pi by 2. So that would mean theta 2 is equal to pi by 2 minus pi by 12. So let's solve for this. And as you can do, we can take an LCM of 2 and 12. So that is, so that's 12. Simply it's 6 pi minus pi, which is equal to 5 pi by 12 radians. In this chapter, we will learn about supplementary angles. Two angles theta 1 and theta 2 are said to be supplementary if theta 1 plus theta 2 is equal to 180 degrees or equal to pi radians. So let's look at this graphically. Let's draw our xy plane. Now this is 0 and 360. This is 90 degrees. This is 180 and this is 270. So if we draw an angle theta 1 A B C, so theta 1 and theta 2 in this case are said to be supplementary. Let's put this theory into practice. So if I told you that theta 1 and theta 2 are supplementary, and if theta 1 is equal to 75 degrees, what is theta 2? So we know from the problem theta 1 and theta 2 are supplementary, and theta 1 is given as 75 degrees. So theta 2 is 180 minus 25, which makes it 105 degrees. If I asked you to convert 105 degrees into radians, you would do it this way. 2 pi is 360 degrees, x is 105. So x in this case would become 2 pi 105 by 360 degrees, which is 15 sevenths and 1524 to 1s are to 12, which is 7 pi by 12 radians.